Hi, hello, welcome to DataWeek's panel, Too Big to Fail, Big Data and Security. Today we have our panel of experts that are here to talk about that, and what we'll do is go ahead and start. My name is Jessica, and we'll start with, why don't we go run through everyone's name and company and tell us a little bit about what each of your company does, and then we'll hop right in.
So I'm Adam Ely. I'm one of the founders of Blue Box Security. It's a mobile security company. But my background is enterprise security.
My name is Deborah Baron, and I'm with Nuix. We specialize in big data extraction of all kinds of data types, based here in San Francisco, headquartered in Sydney.
Hey, I'm Jay Ranganathan. I'm responsible for product strategy at Cloudera. Cloudera is a company mostly known for a Hadoop distribution that we ship. And Hadoop is not really tied to security, but it turns out that our job is to make this stuff ready for enterprises, and enterprises care a lot about security. So my job has been security for the last 18 months, just transitively.
I'm Brian Burns from Proofpoint. We do email security, governance, and archiving.
I suppose I forgot to mention what we do in the realm of security. Our focus is around privacy in corporations, around legal discovery, regulatory compliance, investigations, fraud, and we'll talk more about PII and things like that.
All right, so why don't we go ahead and start at a high level. What, it seems that everyone today is talking a lot about the opportunities. Big data, you can't fail. There's so many things you can do with it. You can visualize it. You can find out what your customers are doing. But you guys seem to probably come from it and see the problems behind all this data. What are the probably easiest to solve security problems you're finding in your work?
So I can say from my experience on the enterprise side, so I was a CISO at Salesforce and at TiVo, and I ran security at Disney. Some of the easiest challenges that we were able to solve were just looking at who was attacking us, gaining a profile of the attackers, and being able to gain more insights into what our real risks were and what attackers were really trying to come after, so that we could better prioritize our defenses. That was the low-hanging fruit, that once we pumped everything together, we could find those patterns the easiest.
Right, so to complement the intrusion and sort of malware side of the house, our clients are focused on compliance and privacy, so data protection. So the low-hanging fruit there are, and it's actually the same issue, companies don't know what they don't know about what's in their data. So step one is typically to conduct an audit or an assessment of information, unstructured information, the kind of information that we all generate on our phones and through email and texts and whatnot. And all of that data sitting out on file shares, sitting in our email boxes, on our phones, on our tablets, on our laptops. And the information that resides there may in fact be unprotected in the clear and may contain private information, health information, credit card information. So conducting an audit is probably the first step.
I come from the Hadoop world, and the Hadoop world is fairly rapidly evolving in terms of where it is in security. At this point, one of the big things which actually made security easy in Hadoop was the fact that if you're dealing with things like MapReduce, which is the popular programming paradigm in Hadoop, there's only so many people in your company who are going to do that. There's like 50 people. So it's much easier to regulate an environment where there's very few people actually using an environment. But that's changing pretty rapidly right now. So there's lots more users coming on with new SQL systems on Hadoop and whatnot. So one of the big challenges, and it turns out it's not necessarily a super difficult challenge either, is handling the new load of users, the number of users who are actually accessing these systems. Obviously, you're using Hadoop as a data store for large amounts of data from all types of sources. There's lots of different governance requirements for each of these data sources. But now you also have this huge onslaught of users accessing this data. So being able to provide scalable security management on top of Hadoop is a pretty important element of what we are doing right now.
We maintain some pretty big data collections on behalf of our customers, and our customers certainly have a lot of concerns about their data being in a big data collection, right? I mean, it's sort of a central place where potentially all their data could be exfiltrated in a single go. So certainly, that's a concern around big data is when you collect all your data in one place, does it make it easier for someone to steal all that data? We've put a fair amount of thought into encrypting the data when it's at rest, or just not storing sensitive data in the first place. To your point of PII, do you need that PII in your big data database, if you can avoid putting that in there in the first place, you can solve just a huge number of headaches. And then, of course, you always want to protect the access to that big data, but if there's nothing too sensitive in there in the first place, then it's not the end of the world.
Yeah, hi, thanks. Actually, funny, I just got done having a talk on why Kerberos is not enough for implementing on these Hadoop clusters. I think one of the things that we're actually really seeing at ZetaSet is while we focus on Hadoop because it seems to be what everyone's looking at right now, I think the rise of distributed system security is really where everything's at and is where everything is going. Very rarely do you see kind of distributed systems like Hadoop kind of used as the end all be all to any sort of system. Typically they're tied into other systems, relational database technologies, things of that nature. So really looking at how to actually make data security permissions inheritable from one system to the other is exactly kind of what we're really focused on. Then you actually add the complexity of adding encryption on top of that, making sure that everything's fault tolerable, high availability, that you don't corrupt data. I think that's really kind of one of the things that we're really going towards.
What are you envisioning from the various perspectives and various kinds of ways you approach data security to be the strategy that will come together once the legal, once the technology, and once the business people align on the same page and get in the same room and talk about this?
I mean, mine's just kind of a continuation of what I just said. I mean, I think that, from a data security perspective and the legal and everything kind of rolls into that, it's managing data as data, right? It's classifying data, understanding what should be where, who should have access, how you should store it, where you should store it, how long you should store it for. It's the same way that we classify IP, right? If I'm Motorola and I have a chipset design, or Intel and a chipset design, and these haven't come out for 2 years, there's a way that I classify that, I secure that, where I store it. I don't put that in, offshore storage because, well, that's proprietary. I don't want a foreign government to take it. Some chip manufacturers had those kind of problems. Big data is kind of the same. You classify the data that you're pushing in there, and you apply the same kind of logic that you would apply to any other data that's stored in your environment. The great thing about quote-unquote big data is you have it in more of a centralized spot, granted unless it's coming from some other systems and you're storing it still on those systems locally or those applications locally as well, then you just actually double the problem. You have two places to secure the data, so now you have to think about that as well. So it can actually complicate it, but for me, from the enterprise side, it's just more of kind of the same. But I'll let some of the big data experts tell me where I'm wrong, hopefully.
Well, I'm the big data vendor, I guess. So I have to say that in general, I agree with them. Actually, one of the big things here is not that the problems have changed. It's that the technology has changed, and the technology doesn't actually have the same controls that older technologies had for a long time. So I was telling somebody else earlier that what we're doing is reinventing stuff that was built 30 years ago, but it's important to reinvent that stuff because it was there for a good reason. And there's a lot of work that needs to be done in the Hadoop ecosystem, especially around Hadoop is one example of a big data system. There are other big data systems which are emerging as well. And all of these things have pretty much the same problem, which is that they're new systems. They have focused on solving distributed computation at scale. That's what they're really, the people who built it were like, let's do that. Let's not start with security. And now once you start deploying this in large scale enterprises, you have to worry about security. And when you worry about security, all these things that were done for classic databases many, many years ago have to be reinvented at the end of the day, and that's just a fact of life, and that's something that we do have to end up spending a lot of our energy and time on. And in fact, that's why people pay us. We invest our engineers in doing this kind of work. And ZetaSet is actually a really good example of a company which is helping out in this space for us as well.
So I guess, to your point earlier that, big data security is really just data security. I think maybe there's a little nuance difference to it, and bear with me with this analogy. We'll see if it goes anywhere. Where all of us in this room probably have like a wallet or a purse, right? Like with us. And like I sort of see that as the pre-big data world, right? Like we have, this is a value, data is a value, and like right now it's just sort of federated in all our pockets. With big data, it would be like as if we took all our wallets and just threw them in a big pile in the middle of the room. And so the way you would approach securing that big pile of wallets versus the wallet that's in each and every one of our pockets would probably be different, right? Like the threats are perhaps a little bit different. The strategies that you could employ would be a little bit different. I think it could be an opportunity, right? Like when you have everything centralized, to your point, like don't have it twice, right? If you're going to centralize it, throw it away everywhere else. But maybe that makes security easier, right? Because now, instead of having 200 databases you need to secure, it's one database, and it just becomes easier. But then again, maybe the risks are higher too. I mean, there's a little bit of a give and take there.
It's really fun going after all of you guys because you have all kinds of great setups. But I'm glad you mentioned high performance computing because that's there's a confluence or an evolution, just to roll back the clocks. When I first started doing data modeling, it was all about structured data. You know, an 8 million record database was massive. And we had to do entity relationship modeling so we could figure out what belonged to what and unhook it from application silos and all that good stuff, right? Fast forward to today, and the wallet problem is an interesting one, but what's common in all of our wallets is our ID, our credit card numbers, et cetera. So there's common themes that you can address across small buckets or large buckets, and there's a lot of risk around large buckets. We've gone sort of from big buckets. Remember when IBM and EMC introduced Content Manager and Documentum, and the answer was put it all in one big place in a semi-structured environment. And then, you know, high performance computing, the reason why we got a patent last year on our ability to do really fast text extraction is because the volume of unstructured data has just overwhelmed structured data. It's like an 80-20 and it's growing even faster. So what do you do about that? Your question was about strategy, so just getting back to that, the strategy that makes the most sense to our clients who are actually putting money down are to take bite-sized chunks, right? So if you're concerned about privacy and you've got your business processes credit cards, then you're under the PCI, right? Private Credit Information Law and Regulation. So you want to do something about that, because if you violate that regulation, you can't process payments, and there's revenue impact. So top-line revenue impact driven off of a compliance requirement to protect your clients. So those are, what I'd recommend strategy-wise is go find those specific projects where you have, the attention of the executive team, where you can manage it and budget it in such a way where it's not something where you have to bring in an army of people to teach them a whole new language, and then get success. And then you can start to build your security program, and it might fall under the CISO. It might fall under the CIO. It might fall under compliance. It might fall under legal. It might fall under a particular business unit or department because they have that mandate.
So that all makes sense. We talked about strategy and, ideally what would happen if we all got in the same room. Now let's talk about reality. What's really happening out there? What are you going in and seeing companies, maybe how are they mismanaging security? That might be something easy to fix, but you're seeing it as a common problem.
So I'll say one of the companies I worked for, I won't say which one, but just before starting my company, we went down this path of trying to figure out, we had so much data. I mean, just one of our apps was creating 1.5 terabytes a day in Dataforce, right? And that's just one app, and we had, 80, 90, 100, something like that were actually critical. We needed to analyze data coming out for security. And we went down the route of, okay, let's use the log management systems, let's use these things. And then we went down the Hadoop route and all these other routes. One of the big problems that we actually did have was we treated it as a skunkworks project, and we actually ended up with, all these different types of implementations around the organization. And we really weren't using these tools for, what they were built for and the power of bringing everything in. And we had like 7 different teams trying to use Hadoop. We had the data replicated everywhere, or I should say just copied everywhere. And so we were just very inefficient and had no idea what we were doing when we went into it. So this was the big problem that we had. And this created security problems for us. It created compliance and regulatory problems for us. Hell, it just created data management problems of who's got the data and, I want your data set. Oh, okay, I'll share this with you. And how do you share that in the organization? So we just completely approached the whole thing wrong, and that was our biggest problem. And I see some of that with our customers today.
So this week, the new HIPAA 2 regs came out. So that's a common problem that everybody's got. And I'll just give you one example. This is a national retail chain that we probably all have spent money at. And their particular issue, so they handle drug transactions, pharmaceuticals. And so they had literally 1 million customer insurance IDs all over their networks, all over the United States. And the funny thing about insurance IDs is they don't follow a set pattern, right? Driver's licenses, credit cards in the United States, there's certain patterns, and regular expressions. I'm looking at a guy in the audience who works for us who's kind of a guru on that stuff. But insurance IDs are all over the map. And so they had 1 million. And so how do you have 1 million search terms and search across 5 different, data centers around the country? So I think those are some of the biggest challenges that Chunking is the answer.
Right. So given that my experience is only how we use big data, the answer is clearly none. Like, we would never mismanage data. I will say, like, one mistake that we have run into is that can be seductive with big data to just store everything, right? Like, data storage can be cheap, especially if you do something like Amazon S3, where you can just like pile up data until the end of time. And it's really nice to be able to go back and ask questions about what did things look like a year ago, or what did things look like 3 years ago, and compare versus today. It's great having that capability, but then you can go too far and then you just store everything forever, and then your costs really start to pile up. And that's certainly something we ran into as early on. We decided we're never going to throw away anything, because we always want to be able to go back and ask, okay, a million years ago, what was things like? And that sort of became untenable faster than we thought. And then we had to decide, okay, what data is worth keeping forever, and which data do we maybe need to age out a little more aggressively? So that's one area where we maybe mismanage big data.
Yeah, so it's really interesting. I think you got to understand, kind of the failings of, before you understand the failings, you got to understand like why people got into big data in general, right? And I can tell you right now, it's typically to answer one of three questions. Somewhere upon high, some executive said, show me how to make more money, save more money, or give me some sort of edge over my competition, right? And so they started constructing this big data, kind of program to put it all together, and kind of to echo, what you just said. The handcuffs were off, right? Let's just store everything in here and treat it as a bit bucket and start going from there. I think what ended up happening, though, is you're seeing that a lot of these systems are not in production. They're still really sandbox environments. And if you ask people, and I think there was a great Gartner quote that said 87% of the Fortune 500 have a big data project in play, less than 20% is in production. And if you ask them why, the thing is, it boils down to, I don't trust the damn thing, right? I mean, I don't trust it to put it online. I don't trust it to put it in production. And if I did put it in production, then I'd have to be accountable for it and have to be audited and things of that nature. So I think where we're really beginning to see these failures are people are trying to treat these distributed technologies and these distributed systems like they would treat a standard relational, Oracle or DB2 type of technology. And it doesn't work that way. And I think that's where their biggest failings are. I think the biggest successes that we've seen are people that actually, come across with an idea of, hey, look, I don't have a background in distributed systems. Let's go, bring in a consultant and actually bring this up to speed, or bring in supplementary software that's not actually located in the open source sector, and actually, use that to cover our compliances or our audit records or things like that. So that's really kind of where we're seeing the success stories as well.
We're certainly seeing a lot of concern about the NSA from our customers from outside the U.S. I mean, I think U.S. customers, to your point, like if the NSA wants access to a U.S. company's data, by law, you are required to give it. But our European customers or Asia Pac, they are concerned that the NSA would lean on us to give them access to their data. And so, we've had to solve that problem in a couple different ways, either by hosting the data outside of, U.S. territory, or something that we do is we do what's called double-blind encryption, where the data that we store in our database, we do not have access to. Only the customer has the keys access to it. So if the NSA came to us and said, give me 100% of your database, we could do that, and they would still not get access to any of the customer's data.
Yeah, I might pick up on that, because my take on the NSA situation is that it creates opportunity, right? And also, they're opening a massive data center. Have you read about this? Where they're collecting, they want to pull not their own data, but all the data they're collecting, cell phone, landline, email, text, and they're looking at the metadata. And for us, that's just bonus. But with respect to deletion and finding, so it's about finding things that look like the thing you're after. Whether it's malware and it's got a signature and it's an object and it's a complex compound object, or it's private or confidential data that's just it's floating around. And so there are a lot of algorithms available today, simple Bayesian, and we do something called shingling. So because things, particularly with health information, when someone talks about a surgery that they're going to have, how do you know what to search for? So it's about understanding language and looking at and just simple, even advanced Boolean, proximity, near, this many words and so on, doesn't capture the way we speak about things, and we speak about things differently all the time. We're developing new language. So I think it's about machine learning, and it's about predictive analytics, and it's a fun time for people that are into data and analytics, not just on the Hadoop side, and or Cloudera, or all the other kind of interesting structured things. We're sort of behind the scenes because we're trying to get all this data and normalize it so you can push it up into the analytics engines. And we also have, investigators like high-tech crime guys and agencies around the world. We have a piece of software that allows them to look at hex and do skin tone analysis and all that kind of stuff. But I think the big data discussions here are more about revenue stuff and trends and things like that. So I guess, that's my optimistic view of all of that.
So I would say with the NSA debacle, I don't know, the scandal, whatever you want to call it, business as usual. Some of our customers have asked about it. Interestingly enough, some of our partners, some handset manufacturers from Asia, some of our partners in Europe have actually had more trouble doing business in certain areas because of this whole thing and not wanting to have to give in to agreements, and that's been kind of interesting to watch. Luckily, it doesn't affect us. But I kind of go back to kind of what you were talking about the data residency of EU and these countries saying, "Oh, I don't want to put it in the U.S." That's a problem we've been dealing with for a long time. It's why we tried to create safe harbor so we could share data between EU entities and U.S. entities. And safe harbor is crap. It's it doesn't really meet the real intents of the EU laws. But hey, whatever, it's what we have. And so these are problems that I've heard from companies that I've worked with that were Salesforce customers. I had to deal with it at TiVo. I had to deal with it at Disney. And so I think the NSA problem of a government or a third party looking at your data is just an expansion of the same fear we've always had with outsourcing, with going to the cloud, with data residency in different countries. I think it's kind of just more of the same problem. And I agree with Brian that if our NSA overlords really want to get access to the data, they probably already have it or they will get it.
So one of the things that we're doing is asking for data. We're asking for data so that we can build this sandbox and do this kind of privacy, so PCI, PHI analysis, to develop methodologies to share. And there is a public data set that's very common in the eDiscovery legal industry, and it's the Enron employee data set that the Federal Energy Regulatory Commission released to the public through FOIA. And it's got it's about 20 gigs of data. It's millions and millions of email. And we ran a test against that, and I think we have a white paper in color. That walks you through some of the techniques and methodologies. And what's great about it is it's just a company's email, right? It's what all of us have. And this stuff is 10 years old. But anyway, the ask here is if anyone has data that they wouldn't mind turning over into a sandbox, this is all sponsored by the Electronic Discovery Reference Model, which is a big industry group that is striving to develop standards and practices and then turn those back over to the community. So if you have any data, let us know. One quick note, the European Commission in 2014 will turn into law where a company can be fined up to 2% of gross revenue if they're holding on to private information that belongs to a European resident. So if you work multinationally and you have European employees and that data is sitting on your systems in the US, you're exposed. So what I would recommend is the metadata approach, right? So what you can do is you can run analysis against metadata against those files to locate things that you need, and then you've got to ask permission, at least in European countries. I'm not familiar with Latin America.
And thank you for coming.
Thank you.